Greetings, mathematicians. Today we're going to wrap up our study of Pythagorean theorem. We're going to talk about the converse of the Pythagorean theorem. We've already touched on this. You've already done it. We just haven't put a name to it. The converse of the Pythagorean theorem just states that if a triangle has side lengths of A, B, and C, and that A squared plus B squared equals C squared, then the triangle is a right triangle. Now, we've done some of these on an assignment before, but we've never called it the converse of the Pythagorean theorem. So let's get a couple of examples down. So just to bring it back to the forefront of our memory. So I'm given a triangle that has side lengths of A is 7, B is 24, and C is 25. Now, if this is a right triangle, we should be able to plug it into Pythagorean's theorem and it make a true statement at the end. So as we do that, we'll say that 7 squared plus 24 squared is equal to 25 squared. Well, let's go ahead and square these. So that'd be 49, and 24 squared is 576, and 25 squared is 625. There's no inverse or anything to do. We're just simplifying this as we can, doing the math as we go. So we're going to add these two together. 49 plus 576 is 625, and we still have 625 on the other side. So this is a true statement. So yes, a triangle that has side lengths of 7, 24, and 25 would form a right triangle. So yes, it is. Let's take a look at an example to see what would happen if it doesn't work. So again, we're given side lengths of A is 5, B is 8, and C is 12. We're going to plug it in to Pythagorean's theorem. So we have 5 squared plus 8 squared is equal to 12 squared. We'll go ahead and square these, then simplify. 5 squared is 25, plus 8 squared is 64, plus 12 squared is 144. Go ahead and combine these two. That gets us up to 89 is equal to 144. Is that a true statement? Absolutely not. So, no. Triangles with a triangle with side lengths of 5, 8, 12 is not a right triangle. So, just remember, when we're checking to see if side lengths will form a right triangle, it's called the converse of the Pythagorean theorem. Okay? I'll give you a minute to finish up on this if you need it before we go on. You can stop this anytime. Next thing we're going to talk about is, now this is something new, finding the distance between 2 points on a coordinate plane. There are other methods to do this, but today we're going to use the Pythagorean theorem to do this. So this is what it's going to look like. We're going to have point A and point B, and we need to find the distance between point A and B. We can't just count the squares because it's on a diagonal, and the diagonal length is the diagonal length of each one of these squares, as we know, which would kind of be the hypotenuse if we made two triangles out of it, is longer than the vertical or horizontal measurement. So what we need to do is we need to form a right triangle between point A and B. So we're going to take and we're going to draw a line coming up from A. We're going to take our straight edge, and from the point A, we're going to go up to the same line that B is on. Then we're going to do the same thing from B. We're going to go from B, and we're going to draw a line to where we intersect the line coming up from A. If you notice, right here we have formed a right angle. And then the distance between A and B then, this distance here is going to be the hypotenuse. So we just need to figure out our measurements. So if I count the steps in between B and the intersection, it'd be 1, 2, 3, 4, 5, 6. So that's a distance of 6. If we look at the distance between A and the intersection, that would be 1, 2, 3, 4, 5, 6, 7, 8. So we have sides on our legs on our right triangle of 6 and 8. So we can plug that in, find the hypotenuse, which in reality will be the distance between A and B. So as we set it up, these are legs, so 6 squared plus 8 squared is equal to C squared. We need to go ahead and simplify these by squaring. So 6 squared is 36, plus 8 squared is 64, is equal to C squared. we need to go ahead and combine these two. So if we combine these, we get 100 is equal to c squared. We're not interested in c squared, we want to get c by itself. So we need to find the square root of c squared. Since we find the square root on this side, we need to find the square root on the other side. So we end up with c is equal to 10. Since we don't have a tag, we'll just put 10 units. So the distance between point A and point B is 10 units. And just a review of that, we extended a line from point A up until the same level as B. Then we connected the point from B over to the line we just drew from A, and that formed our 90 degree, and it formed our two legs of our right triangle. And then we found the hypotenuse, which is the distance between A and B, by plugging the legs into Pythagorean's theorem. Let's do one more of these just to make sure we're clear on it. Again, on this one, we've got 2 points on a coordinate plane. We're going to start out by drawing a line from point A down into the level of point B. So as we draw that, we're going to come down 1, 2, 3, 4 units. So that's 4 units. Then we're going to extend the line from B till we intersect this line. So as we do that, we've got 1, 2, 3, 4, 5 units. And again, in between there, this forms our C, which is our hypotenuse, which is what we're looking for, the distance between points A and B. So let's go ahead and plug that information into Pythagorean's theorem, which those are legs. So we have 4 squared plus 5 squared is equal to c squared. The square of 4 is 16. The square of 5 is 25. We don't know what c squared is, so we just bring it down. We combine these two. Well, 16 plus 25 is 41 is equal to c squared. We don't want c squared, we want regular c, so we're going to find the square root on both sides. That's going to leave me with c is equal to, 41 is not a perfect square, so as we do this, we're just going to round to the nearest tenth. And if you'll follow along on your calculator, I think we'll come up with a number that rounds to 6.4. So we're going to say that that's 6.4 units. And we found the distance between point A and point B. I hope this clarifies some things for you, and like I said, this wraps it up for us. And we'll do a review soon and get Pythagorean theorem under our belt. That's a cut.